Good morning, all of you. So, Nectar welcomes you all to on day 10 of our 3 week summer training program on geospatial technology. At as you all know, we are Northeast Center for Technology Application and Reach, headquartered at Shillong, currently operating from Survey of India campus, Bonibray State. So today we will be covering the emerging trends in geospatial technology. So initially we will be having a theory session on LiDAR applications, then thermal remote sensing, followed by WebGIS, and then we'll be having some kind of data visualization of these two kinds. And today, the speaker for today is Dr. Chandan Goswami. He is scientist E from Northeast Space Application Center, or NISAC, as you all are aware about it. His PhD in soil sciences and agriculture chemistry. He has expertise in applications of remote sensing of agriculture and soil. He has more than 13 years of experience working as scientist at NISAC and total more than 20 years of experience in various application areas of remote sensing and GIS. He has more than 80 publications in various international and national journals. Uh, I welcome Dr. Goswami at Nectar. Now I request Ms. Panjuma Kotaki to facilitate our speaker for today in the traditional Assamese style.
Thank you. Thank you. Okay, ऐसे एक photo ले लेते हैं. Thank you.
Thank you, Ms. Kotaki. Now I hand over the mic to Chandan sir to start the proceedings for today. Thank you all.
Okay. Hello. Good morning to all. Mic is working, no?
Yes.
It's working. Okay. So, my introduction, though, it has been given to you. So we will be spending your half day together, because the timeline or the course content it was shown. So I have made some small changes in that actually. So initially it was shown that your presentation on LiDAR will be there, then there will be a break, then practical session will start. Then after lunch it was shown that thermal remote sensing part. So what we have planned, that we will cover the lectures in the first half, and after lunch you can go for your practical sessions. So that is the plan. First I will start with LiDAR, then we will break for some time, then I will start thermal remote sensing, then some basics of your WebGIS. So three components I am going to cover. So then after that your practical session will start after lunch. So since I am going to spend half of the day with you, so I feel that I should know you personally. So my introduction is given. I am Dr. Chandan Goswami, working as a scientist in NISAC since 2009. So and my background is in your PhD in soil science and agricultural chemistry, working in the areas of agriculture and soils in NISAC. So you can also give your introduction. Let us have a friendly environment first before going for the presentation. So you can start from you. Yeah, mic not required. In room is okay. Without mic also you can. Okay. Then you are from which institute?
I'm studying in William Carey University, that is in Meghalaya in Shillong.
Okay.
Yeah, I'm doing my
MA in
geography.
MA in geography. Okay. In Meghalaya, Shillong.
Good morning, sir. My name is Dajob Lindonglang from Shillong, and I study in William Carey University in Shillong.
MA geography.
Yes, sir.
Okay.
Hello, good morning, sir. My name is Longbak Paromi from Meghalaya, Shillong. So now I'm doing my MA in Geography.
From which institute?
William Carey University.
Okay. You three are from William Carey.
Good morning, sir. Myself, Litama Basumatari. I belong from Assam itself, from Karbi Anglong district. I have passed my master's in Assam University in Department of Geography. As well, I'm now pursuing my PhD in Department of Geography. I have taken my topic in agriculture geography.
You are doing PhD in Assam University itself?
No, sir, in USTM, University of Science and Technology.
Yes.
Good morning, sir. I'm Pooja Talukdar from Guwahati. I have completed my MSc in Geography from Cotton University, Guwahati.
Okay.
Good morning, sir. My name is Nikita Gogoi and I am from Guwahati and I completed my MSc in GIS from Bangalore University.
Okay. MSc in GIS.
Good morning, sir. I'm Anjan Mosor. I am from West Coast Hill, but I study in Shillong, Meghalaya. I'm study MA Geography
Where did you study?
in Shillong, William Carey University.
William Carey. Completed or you were
No, still
you were a
study.
student,
Yes.
present student?
Yes.
Okay.
Morning, sir. My name is Senam Padu. I am from Arunachal Pradesh. I have completed my master in William Carey University, Shillong.
Okay. MA Geography? Okay.
Good morning, sir. My name is Kiwi Bori. I'm from Arunachal Pradesh. I have completed my MA in Geography in William Carey University.
Okay. Okay.
Sir, I'm Barihun Almona. Completed my BSc Geography from Senate College.
Okay. Have you registered for MSc? Not yet.
No, sir, I completed BSc
PSc,
Geography.
but not registered for MSc. At present, what you are doing? You are not studying anymore.
No, sir, still apply the CUET.
Okay.
Good morning, sir. My name is Julka. I got my degree from that college.
Okay. Geography, no? Degree, bachelor. Okay.
Good morning, sir. I'm Berwi M. Sangma from Tura, Meghalaya, and I'm pursuing my master degree in Geography at William Carey University, Shillong.
Okay.
Good morning, sir. My name is Super Strong. So I'm from Joai, Meghalaya, and I have completed my studies in BTech Civil Engineering.
Okay. You are BTech Civil Engineer.
Yes, sir.
At present, you are not pursuing your higher study.
Right now, no, sir. I'm
Okay.
just preparing some.
From where did you pass?
I passed out from this Regional Institute of Science and Technology.
Nearest.
Not nearest, sir. It's
Okay. This
here
USTM
in
campus.
USTM campus. Yes, sir.
That regional institute.
My name is Panjuma Kapati. I have joined Nectar as a senior analyst this year.
Okay, she is not trainee means.
She is from MTech in Geotechnical Engineering.
You are from where did you pass?
So I passed my graduation from Jorhat Engineering College and my master degree from Tezpur University.
Oh, and you have joined as a senior analyst there. Okay. B from Jorhat and MTech from Tezpur University. Fine. So now, shall we proceed for the presentation? So, it may be exhaustive for you because listening to lectures for long is not encouraging, but I have some limitations, so I cannot spend the whole day. That's why the entire presentation we are arranging in the first half itself. So in the emerging technologies, first we will discuss something about the LIDAR. So I think as of now, since this is the last day of second week, I think most of the basics you have covered, isn't it? Basics of optical remote sensing, basics of microwave remote sensing, basics of hyperspectral remote sensing. So today we are coming to another type of remote sensing, that is LIDAR remote sensing. So what we will try to cover here, we will try to cover the entire presentation in 8 your heads. So first we will see how the LIDAR technology developed or the history of LIDARs. Then some basic principles of LIDAR we will study. Then we will try to know the LIDAR platforms. By this time, do you understand what platform means? Some idea you have platforms? If have you heard about your LIS-3 satellite, LIS-4? No, sorry, LIS-3 sensor, LIS-4 sensor. So what is the platform for LIS-3 and LIS-4? LIS-3 and LIS-4 are present where? Or you haven't heard? You have heard about LIS-3 and LIS-4 or not? Okay, actually what happened? LIS-3 and LIS-4 are present where? It is present in earth surface or water surface? Where they are present? LIS-3 and LIS-4 are present? Huh? No, they are present in space. So that means they are space-borne sensors. So that those are the platforms actually. If it is in earth surface, then you can say, so I will come. So I am giving an idea means what platform means. Okay. Then we will come to the components of LIDAR. All sensors used to have some components. So maybe in microwave and hyperspectral you were told about the components of those sensors. Now we will discuss about the components of LIDAR. Then LIDAR data acquisition. So once you know the components, then you have to know how the data are acquired. Then some basic characteristics of LIDAR data. Then processing of LIDAR data. In fact, I think after lunch you will be having practical also on that. And finally, the what we all people want, that is the applications of LIDAR data. So this is the overall content. So if we see the history, so the title of this program is Emerging Technologies, but you see the history. It started in 60s and 70s, but still we are talking this as an emerging technology. Though we have completed 50 years, more than 50 years, in fact 60 years we have completed, but still it is emerging. Why it is emerging? Because LIDAR has many disadvantages also. So though it has advantages, there are disadvantages. That's why we could not overcome all the disadvantages in last 60 years. That's why it is still emerging after 60 years of its invention. So, first, before going to the history, because you see I have mentioned a word laser. So I think I should show one slide first to you, because from LIDAR straightway we are coming to LIDAR. Why the laser word is used? Let us see this first. So LIDAR actually, the full form of LIDAR is light detection and ranging, but it is commonly known as laser radar. Did you have your class on? I think you need not to write. In fact, I think they are going to share, I think, presentation. So if you write, sometimes you lose your you lost your connections. So it's better you listen and then you take the presentation. Simply, it will be easy for you. Need not to write. They are going to share. So light detection and ranging. So commonly it is called laser radar. That's why in the history I have mentioned the word laser. So I came to the third slide, skipping the second, so that you know the common terms actually. And laser, you see the full form of laser, I think you all know, because laser is very popular now. Everywhere you go to a tourist place, there used to be laser shows. So light amplification by simulated emitted radiations. And radar is radio detection and ranging. Also, have you studied about radar in this course? Have you heard the word SIR? In microwave, did anybody mention about the word SIR? What is that? What is that SIR? SIR is synthetic aperture radar. That means radar you have already studied. No, isn't it? On Monday you had a class on radar. Monday you had class on hyperspectral and microwave. Microwave covers two components. One is your active microwave and another is your passive microwave, isn't it? So active microwaves work on the principle of radar. Passive microwave, can you tell in what principle it works? Active and passive you know or not by this time? You have completed 10 days, na? 5 plus 5, today is the 10th day. Active and passive you understand now, everybody? So give me one example, what is active? Now first give me one example of passive. Passive is more simpler. Passive remote sensing. Anybody? Hmm? Huh? Yeah. What you were telling? No. Leader is not passive. Passive is you and me. We and me, you and me, we are talking. We are sensing passively, because you see here to sunlight is not coming, but these bulbs are coming. Bulbs are illuminating you. I am seeing you. That is, your energy is coming from that bulbs. You are illuminated and I am seeing. So you and me, we are talking. We are seeing each other through passive remote sensing. But in case of active, the energy has to be sent by the sensor. That means source of energy and your source of detector should be same. Here source of energy is these lights and source of detector is my eyes. So they are different. But in case of active, they will sit together. That means energy will be sent from the same place and the detector will detect in the same place. So radar are active, and in microwave radiometers are passive. So in microwave there are two components, radar and radiometer. Radar is active microwave, radiometers are passive microwave. So here we are telling the word radar because radar is active remote sensing. That is why it is called laser radar. Okay, now we will come back to history. So that is why the word laser came in 1960s and 70s, because the leader started with laser. So 1960s and 70s, so laser remote sensing instruments were developed, and they were first actually used for oceanographic and atmospheric. And in fact, let me tell, in today's date also, lidars are mostly used for atmospheric and oceanographic studies, mostly atmospheric, not even oceanographic. Space-bound lidars, okay, and other lidars are used for as per your requirement. You are a civil engineer, you will know lidar is used extensively in civil engineer, but that is not space-bound lidar, because from space the information we get is not at all useful for a civil engineer. For construction, it is not at all informative. What was your degree in engineering, Jorhat? So you are also civil engineer. Okay, so you are civil engineer. Fine. Then it is your altimetry systems were developed. So altimetry, from the word itself, I think you understood what it measures. Altimeter, what it measures? Do you have any idea? Altitude. Altimeter is altitude. From the name itself means some idea you used to get. Then in 1994, and let me tell one thing, lidar is used in your military applications also. Generally active remote sensings are mainly used for military or intelligence purpose, because they want day and night monitoring. Passive means we want a source of light. So here this room is small, these bulbs are working, but you imagine about the earth, how the earth will be illuminated by lights. It is not possible. Only sun can illuminate, and sun can illuminate in the daytime. That means at night time passive remote sensing will not work. So for military or intelligence people, they have to monitor day and night. For them active remote sensing is a must. So they rely on mostly microwave, lidar, thermal, those things they rely more. Of course, thermal, in microwave also there are active and passive. In thermal also mostly they are passive, but they have day and night monitoring capability. So I will come in my next lecture. Okay. So the commercial airborne lidar, actually it started in 1995. That means we are almost almost 15 to 20 years of old. And 1996 is Mars Orbiter Laser Altimeter. This is for planetary studies. We will not focus much. 1997 Shuttle Laser Altimeter, and 2000. So this is used for flood. Okay, this from 2000s you see actual applications. Actually, in LIDAR in today's date, it is mostly used for disaster management. So in today's date, LIDAR is most extensively used for disaster management, and that's why it is more relevant for your civil engineers and urban planners. LIDAR data are mostly used for these. They are using mostly because one more reason why they are using, because this data acquisition is very expensive. For natural resource monitoring and all, it is not so possible for extensive monitoring. But for disaster management, it comes to the life of a person. That's why cost doesn't matter. In those cases, LIDARs are used. We will come in examples. So this is I have already shown you. So LIDAR, laser, and radar. So if we, why I am showing this? Because all remote sensing, they are based on electromagnetic spectrum only. I think every person has shown this. In all presentation of remote sensing, this slide will be common, because somebody will be working on, if it is microwave, you see the microwave person will highlight his or her microwave component. Then if it is your thermal, there also this region will come. Then in our case, it is mostly visible region, because it is light detection and ranging. It is either in the visible region or in the near infrared region. LIDAR will focus on that. So that is the small area where we are going to work. Okay. So laser, actually what I am here trying to show the basic principles. I was telling you that it is a active, it is an active remote sensing. So energy has to be transmitted. Energy has to be transmitted by the sensor itself. So energy will come to the target, then target will reflect the energy, and reflected energy will be detected in the detector. You see, source of energy and source of detector is the same place here. So it is, targets are not illuminated by your lights, means alternate lights. Okay. Now we are coming to platforms. From this slide, I think you will be able to understand what does platform means, because I have pasted one image also along with the platform. So you see, terrestrial means it will be observed on the surface, okay, mostly using tripods, terrestrial lidars. Then second is your mobile lidar. Mobile lidar, generally sensor is put in a vehicle is to fly. Mobile lidars are mostly used for disaster management. Civil engineers and urban planners, they are using mobile lidars. Then airborne lidar sensors. So of course earlier most old sensors are actually airborne sensors, lidar sensors. So then you came to the spaceborne lidar sensors. So examples we will give. Spaceborne means platform will be space only. Some satellites will be there which will be carrying the lidar sensor. And recently, actually, UAV technology has gained lots of momentum. I think you had one lecture also on UAV. So why UAV gained momentum? Spaceborne sensors, they used to see a large area. Sometimes it is observing a continent at a time, but our requirements are always different. The requirements are confined to a small pocket. Like you people know, there was a problem in your Haflong area recently. So getting information on those areas, getting satellite data, especially it was during cloudy day. so you cannot get optical data. That means passive remote sensing will not work during summer. So then again, you're getting your India, we don't have in fact your high end, of course we have microwave sensors, but their sensors coverage is very less, and repeativity is one issue. Repeativity, the word you have heard I think by this time. Repeativity means the time gap between two acquisitions. So by the time repeativity used to be generally 25 to 30 days in most of the remote sensing satellites. So if somebody wants to see the half-long area immediately, we don't have option also. So in those cases actually UAV used to give good support. Somebody can go quickly fly and get the images and all. So that's why this has lots of advantages nowadays. And keeping those things in mind, lidar sensors also means developed so that it can fly with UAV. Okay, now can you tell me out of these platforms how the weight will vary? Weight of the sensor will vary. Means can you give some idea? Means weight of the sensor based on the platform, how it will vary. So I will give you one example. Airborne lidar sensor will be heavier or lighter than UAV borne lidar sensors. Heavier. Why it will be heavier? Yeah, you are correct. Answer is correct. But you now give the reason also, so that I understand that you are not saying just like that. Airborne sensors are heavier than UAV borne sensors. Why UAV borne are lighter? I am giving the question in a simpler way. Have you heard about the payload capacity? Payload capacity is the capacity to hold weight. Capacity to hold weight. And do you know the payload capacity of UAV? Common UAV is used. Have you been told on Wednesday? Yeah, around 2 kg only. Around 2. That is the disadvantage actually. Getting active sensors, because active sensors they have to have their energy also, because they have to transmit power. Active sensors used to be heavier. So preparing or developing lighter sensors for UAV is the struggle. So in case of UAVs are very useful, but getting the sensor for UAV is difficult because their payload capacity is less. They cannot hold much weight. Of course, there are some your fixed wing UAVs. So UAVs are also different types. Some are copters, some are fixed wing. Fixed wings can hold more because they are small aeroplane, you can say. So if airborne lidar is 15 kg, so at least copter they can carry 4 to 5 kg. But in most common UAVs, what we are using copters, they cannot go beyond 2 kg. 1.5 2 kg is the highest. Okay, these are the platforms. Now you understand what platform means. Okay, this is not only for lidar. For all remote sensing sensors, platforms are common. Platforms are common for all. So you will get the idea. Now we are coming one by one to the platforms, means how it is. So I think in the image itself, I have nothing to say. I have nothing to say actually. Seeing the image itself, you will understand how it works. You see, altitude, what I mean, that means altitude is I am showing from the surface of the earth, means that altitude I am saying. That report height means sensor height from the ground I am saying. So generally they are placed 1 to 2 meter above ground. Then scanning view is side view. You can see how it will sense. It will go parallel to the earth surface. That means side view. Then scanning type, actually instead of range I should tell type. It is point information they will collect, point by point. Okay, and density of point, they are very dense. Yeah, but this is point. It will come. I will show you. It will gradually come. They can collect in line. They can collect in ellipsoidal shape also. So there are many ways they are collecting, but in case of your terrestrial leaders, they used to mostly collect in point information they used to collect, and density is very dense. And can you tell me what is the advantage of dense? If we get more points, what will be the advantage? Or you will, if it is sparse only, which will be better for us, dense point or sparse point? Dense point will give the 3D image itself, means you will get a complete picture of the area if the points are denser, and sparse point you will not get the clear picture of the target. So, if denser, more dense means more informative. Okay. Then wavelength, it is using 500 to 600 nanometer. This wavelength is in which range? This is in microwave range or thermal range or radio wave. This wavelength from the electromagnetic spectrum you are every day seeing, everybody is saying, can you tell what is this wavelength? 500 to 600? Yeah, this is visible. 400 to 700 is your visible range. So, LIDAR itself, from the name itself, it is coming light detection. So, light is generally we used to mean by the visible range. So, accuracy is also important. So, in remote sensing this is very important. Vertical accuracy is 2 to 10 centimeter and horizontal 3 to 10. That means these are very accurate. Now, can you tell me your horizontal accuracy of LIS-3 sensor? Because why I am repeatedly telling these sensors, these are the two Indian sensors, LIS-3 and LIS-4, which are most commonly used by the students for their MSc, PhD works. Besides the government work, students also use them extensively because they are almost free. 1 year old data you will get free, and current data you will get in very less price. So, these are the data which are most widely used, or you are more familiar with foreign sensors. You do not know about LIS-3 and LIS-4, then you tell me about Sentinel. Horizontal accuracy of horizontal resolution, let me tell, instead of accuracy. Have you heard about the word resolution? Everybody is telling spectral, spatial. Then spatial resolution of LIS-3 is how much? It is 23.5 meter. Need not to see your notebook because this is not exam, but you should, means by this time, since you have spent 2 weeks, some basic things you should know to differentiate. Means differentiate, because I am talking about LIDAR, but it is not that you should forget about optical. So, LIS-3, LIS-4, these are all optical remote sensing. So, because you have to understand optical, LIDAR is to overcome the problems of opticals. So, if you do not understand optical, there is no meaning of talking about LIDAR. So, that is why I am going back also every time, going back to make you feel the difference. In LIS-3 you see 23.5 meter, here I am telling about centimeter. You see the advantage of this LIDAR. That means you will get more detailed information in terrestrial. Okay. Then mobile. Mobile also altitude a bit higher because it is generally placed on the top of a vehicle, sometimes in the back side also, in the rear side of the vehicle also it is placed. Here also you see you are getting density is very dense, and mobile LIDARs are mostly used by your urban planners. They used to roam in the city, they used for their detailed planning. And here also accuracies are very high. You see vertical is 2 to 10 centimeter, horizontal is 3 to 10 centimeter. Accuracy you should remember, that is the thing what remote sensing makes difference one from another. Accuracy is the main thing. You see now airborne. In case of airborne, you come to accuracy directly. Come to accuracy, it is showing, you see it has come to meter now. Horizontal accuracy 10 to 15 meter. That means it is coming closer to LIS-3. LIS-3 I told 23.5 meter. So, in case of airborne, it has come closer to your optical. But you see the wavelength here it is used. What is the range of that wavelength? Can you tell the name? 1000 to 1600. Is it visible? It is not visible. Then what it is? It is infrared region. After visible, it will near infrared will come. After near infrared, infrared will come. After infrared, thermal will come. After thermal, microwave will come. Like that it will go. So and based on those categories, we are working. Remote sensing people are working. Now spaceborne. Spaceborne, you see, spaceborne also accuracy is your vertical accuracy is almost similar, a bit higher, 1 to 10 meter, but horizontal accuracy is much coarser, because as you go far from the target, always accuracy is to decrease. And you see point density also, it is low in case of spaceborne. That means spaceborne, so since density is low, that is why I told spacebornes are mostly used for atmospheric or oceanographic studies, because they are in water and air. Variability is very less with respect to space. If we compare with your earth, or your what to say, solid surface, solid, liquid and air, if we consider three components of your earth system. So variability is highest in your solid, then it goes to your then it goes to liquid, then air used to have less variability. That is why for air, atmospheric and oceanographic studies, spacebornes are better because it is less accurate. And one more thing, spaceborne sensor sending the your energy to surface, that is also one challenge, but sending the information to the atmosphere, it is easy. Getting energy from the atmosphere is easier. You require less energy to study, but if you need to send the pulse to Earth's surface from the space, it requires more energy. That is also another point why generally surface studies, satellite leaders are not used. You require lots of energy to send it, because the energy has to go back also. It is not that only you have to send. This energy after hitting the target, it has to go back to the spaceborne sensor. Those are the issues why these are not extensively used for Earth's surface studies. Now coming to UAV. So the latest one, you see vertical accuracy is very high, 5 to 20, and horizontal is also 10 to 20. It is quite good, you see. And okay, do you know the spaceborne satellites vertical accuracy? Oh, sorry, horizontal resolution. What is the highest horizontal resolution? You can tell a range with the name of the sensor. Can you tell? You cannot tell. In optical remote sensing, do they show the history of optical remote sensing? Because in the history actually it used to come like that. First there will be 1 kilometer, then it will come down to 1 meter, then that way it used to come. So the horizontal resolution in spaceborne sensors, generally we used to get maybe sometimes your 50 to your maybe 0.5 to 1 meter, you can say. The highest means you may not expect more than that, but here you see we are getting up to your 0.1 to 0.2. So that is the advantage, but disadvantage we told, that developing the sensor, because sensors are heavier, so the payload capacity of the UAV is the limiting factor. Okay, but I expected that you could have remembered those things. History of remote sensing in India, have you been told? No, I think basics of remote sensing itself people used to cover like that.
But the basics of remote sensing in India at such
Okay. What way let me tell you something. In India actually first we started with 1 kilometer horizontal resolution imagery. Then we came to 500 meter, because the development of remote sensing generally it focuses on your improving the spatial resolution only. That is the thing actually mainly what people are doing. So then from 1 kilometer, 1 kilometer you understand, 1 kilometer means the objects within 1 kilometer are considered as same. In 1 square kilometer area, the space-borne imageries they took it as a single object. In 1 kilometer, you see Guwahati city, how many things are there in 1 square kilometer area. But for the sensor, it is one object. So that is the disadvantage. Then it came down to 500 meter. That means half kilometer by half kilometer. Half kilometer by half kilometer. Then also it is not sufficient for your cities. It may be okay for a large forest area in Arunachal Pradesh. There are many from Arunachal Pradesh. So in half kilometer or even in 1 kilometer also Arunachal Pradesh 1 square kilometer forest itself they will get. But in cities there will be so much of variations. So then gradually people improved it, and in India now we have your this 4 sensor, that is your 5.8 meter of spatial resolution. That means object sitting means 5.8, it is 6 meter. 6 meter means you and me, I can say that may be less than 6 meters. So me and you can be differentiated. So that is the way it is improving. Okay, now I am going to give some examples of your space-bound lidar sensors. So some of the sensors we are giving. So you see satellite is the, here what is the platform, can you tell for this sensor? Sensor name to I have written glass. So what is the platform name here? I told you in the first or second slide, na? What is the platform for this? ICESat is the platform. ICESat is the platform. In the ICESat satellite, this sensor is mounted. Okay, glass sensor is mounted in ICESat satellite. Satellite is not the sensor. In the satellite there are many sensors. In the satellite there may be 4 or 5 sensors, like your ResourceSat. Have you heard about ResourceSat satellite? I think you have been told. So ResourceSat is the most common satellite of India, used for natural resource monitoring. ResourceSat is having 3 sensors, AWIF, LIS3 and LIS4. So that means, so like that in ICESat there may be many sensors. Out of that, one is your lidar sensor. So I am highlighting the lidar only. Got it? So since the presentation will be shared with them, yeah. So I will not take much time because you will get the details in the slides. So this is one. But one thing you see that resolutions you can see. So horizontal and vertical resolution. Horizontal is 172 meter, and purpose you see atmospheric mainly, because space-borne, since I told you space-bornes are mainly used for atmospheric and oceanographic studies. So this is another. Calypso is the platform and sensor is Calliope. Okay, here horizontal resolution improved to 70 meter. This is also mainly atmospheric studies, aerosol and cloud. This is another. Okay, this is another sensor. Here also resolutions are not given, but this is purpose is a bit different. You see volcanic sulfur dioxide is studied here. So that means surface studies also it is covering. So this is another sensor name is Aladdin. You see, it's interesting name, easy to remember, and your platform is ADM. And mostly previous sensors were from NASA, but this is from ESA. ESA, you know, no? European Space Agency. So here resolution is very coarse, 3.5 kilometer. Then ICESat also improved. It is ICESat 2. It came. Resolution also improved to 15 centimeter. Okay, this is another sensor. Now we are coming to next. आपको टी ब्रेक कब होता है? I will No, I will take maybe another up to 10:45 to 11 ये खत्म करता हूँ. 11 तक खत्म करने से ठीक है ना? First we will finish by 11. 10:45 to 11. और आधा घंटा है. You are worried I think now. Because I am taking more time because we are going very slow. Since you are beginners, I feel na? You don't have much experience, so it is better to go slow. So now we are coming to components. So platform is also one part of the component. Platform we have discussed. Second is the scanner. Third is your ranging unit. Fourth your control, monitoring and recording. 5 is this differential global positioning system. Have you been covered any class on GPS? Yeah, because in leader, why I am writing differential? Because in differential, I think you know there used to be 3 components in differential. One sensor will be on one GPS will be on the platform. Okay, platform will carry one GPS. Then your ground station will also have send some information, and third will be your satellites. These 3 components are there. And differential GPS, the advantage of differential is that the accuracy used to increase in differential GPS. So it is, you can say it is highly accurate. In maybe in centimeters they used to give. In normal GPS they used to give in meters. Maybe you will get 4 to 5 meters of accuracy. But in differential you will always get in centimeters. So for leaders, since it is point information, you were talking na, it can go in line. You see now in the right side you can see the scanning patterns, parallel scanning, so zigzag scanning, ellipsoidal scanning. So these are coming, your points are coming. So I will come part by part. Now since we have discussed about the platform, now I am talking about the scanners. So scanners are based on the actually mirror in the sensor, that pattern changes. If the mirror is oscillating, then you will get jet shaped. If it is rotating, then you will get parallel. So like that, in ellipsoidal also you will get, and these are the different types, the how the data are acquired in your leader. Data acquisition. So there are different types actually of data acquisition. Single pulse, single wave. This is the most simplest, or it is called linear mode leader, LML. Then multipulse in air, that is one. Then next is your full waveform, then multispectral, and gauger mode or single photon leader. These are the 5 types. So these are very long text, but I will not read much. I will give you some highlight only one thing. Single linear mode leader means single pulse, single wavelength, means you will understand. One pulse will be released by the sensor, it will hit the target, it will come back to the detector. After that only the second pulse will be sent. That is the pattern means. After getting the getting the energy from the target, only second pulse will be sent. So that means time lag is high in single pulse. Single pulse, that is what I am telling. Single pulse means sensor will send the pulse to the target. Target, after hitting the target, it will come back to the detector. So unless it reaches detector, second pulse will not be sent. Got it? In case of multipulse, before receiving the pulse by the detector, second pulse will be sent. So that means time lag is less in multipulse and time lag is more in single pulse. More pulses will be sent in multi, but in single it will wait till it comes to the detector. So single is the simplest form of LiDAR, you can say. So the texts are there highlighting the things. So you can.
Based on what will they take it cover, that will be single pulse or multi-pulse?
No, actually sensors are developed like that. Sensors are developed like that. Then initially when the LiDAR sensors were developed, obviously they will develop the simplest one. But then they saw that it takes long time to acquire the data, and if it is a moving, if it is terrestrial or your tripod based, then there is no issue. Pulse rate is slow, it is fine, you will wait only, it is static. But in a mobile platform, if pulse rate is slow, that means you are missing the information. Got it what I am telling? That means if the sensor is in a vehicle is moving, so in the single pulse what will happen, it will send the pulse to a target will send back, till it comes back it will not send. That means for one target, one 3-story building, you may get only 1 point. That is the disadvantage of seeing. So that way the sensors were developed. Simplest initially started, then they got the disadvantage. Then if the platform is mobile, you will get less information, because vehicle will move by that time. By that time second pulse goes, it will go to the next target. You cannot get more information for a target. That means one tree, you cannot get the tree height. For one building, you will not get the building height. You will get only 1 point from that building. But if you can hit multiple times, then you can get the entire building height, and 3D models are developed. From LiDAR, generally in urban planning, they used to make the 3D model. So multiple pulses are always better. But I think the development of that sensor is more complex. That is why initially it started with single pulse. Okay, multispectral LiDAR. So this here I will tell in multispectral what will happen in your platform. I was showing generally LiDARs are working in one spectra. In multispectral it will work on 2 to 3 maybe. You see here they are using 532 nanometer, 1064 and 1550 nanometer. So LiDAR may send your it is called your spectral channels. Spectral channel, you know or not? Have you heard about spectral channels? Spectral channels means number of bands. Have you heard or not? Number of bands, you know, that is the spectral channel. So in case of LiDAR, generally they are using single spectral band, but in this case they are using multiple spectral bands. You see there are 3 bands they are using: 532, 1064 and 1550. So that is the basic difference from your previous one and this one. Multispectral. Multispectral means what? Again it requires more energy, because at one go it has to send three channels, energy from 3 channels. If it is single channel, only one channel will be used for sending the power. So these are more complex sensors. That means you require more energy. Okay. In our case, optical remote sensing, all sensors are multispectral only, isn't it? Whatever you have read till now, all FCC you could make. FCC you have heard, I think, false color composite. False color composite, how it is made? It is made of combining the bands. So if it is the single band, you cannot make false color composite. That means, have you seen DEM? DEM is only single color. That means DEM uses only one band. Only one band it is using. One band only. Cartosat DEM. Cartosat is using only one spectral channel. So that is why it is black and white. If it is multispectral, then you can use the channels to make color combinations. Okay, now I am showing one thing. LiDAR data acquisition. One picture only I am showing. So for a tree, how it is acquiring. So some parts are your sent back from the top itself. Some parts are coming to some middle point, and some are coming up to the ground level. So red are coming from the top, yellow are coming from in between, and green are coming from ground. You see a 3D picture has come. 3D picture has come. This is the detail. But LiDAR data's expenditures, you know. LiDAR data is very expensive. That is the biggest disadvantage of LIDAR. This is the picture, it is showing airborne. So, in airborne LIDAR, the Indian airborne LIDAR, it is to be flown by your NRSC, National Remote Sensing Center, that too on demand base. On request basis they used to fly, and it cost around 15 to 20,000 per square kilometer. Per square kilometer 15 to 20,000. In our remote sensing data, it is hardly your 5 to 10,000 per 100 square kilometer. That means you see the price difference. So, LIDAR is not a joke. Since though it is started in 1960s, people are still emerging because of the cost component. Since it is expensive, it is not extensively used. Now you got the idea how it is data are acquired from the LIDAR. Then I am showing some sources of free LIDAR data. I think afternoon session they will try to show you something. So, some sources are listed. So, I think you will get it. So, I am not reading the things. Free sources of LIDAR data to understand the things. Then characteristics. So, some basic characteristics. It is a point information, and you will get the XYZ information. You know how Z information is we are getting, because getting XY is very simple. In all satellite, all remote sensing data used to give you X and Y, but Z how it is giving? Z how it is giving? To get the Z information, you have to take the reading of same place from two different time intervals. Then only you will get the Z information. Z means your that information used to be given by your those sensors only, which can take reading at different time intervals. That means one point has to be hit by same point has to be hit in different time intervals. Then only Z information will come. One point hitting once, you will get X and Y. One point it is hitting more than once, then only you will get Z. So, in LIDAR data you will get Z information also. That is why here it is shown particle accuracy every time. Okay. So, in the lower part, if you background image, if you see, we are showing how from the LIDAR data 3D your model can be generated. In a landscape, how the data reflected or data acquired by the LIDAR can give you one idea of the landscape. So, here we are showing some basic reflectivity of some your natural components or compounds. See here, I want to highlight one thing, that your snow is 80 to 90%. It is same with your satellite remote sensing. In optical remote sensing also, snow used to reflect very high, isn't it? Can you remember? In optical remote sensing also these things were shown. What is the reflectivity of common material? So, it is almost same, because this is also used in the your visible as well as your near infrared region. But one thing you see, highly reflective object may saturate some your detectors. What it means? So, seeing the table, you may feel that those bodies or those materials we are reflecting very high, they will be very good, but it is not. If 100% means it will saturate and it will be detector will be blank. So, there should be a difference between incoming radiation, incoming energy, and your that's backscattered or the reflected energy. There should be a difference. If the 100% is coming, then it will be blank kind. So, that is called your saturation of your detector. So, very high reflective materials are not good for your LIDAR remote sensing. In turn, what they used to do, they used to avoid your vertical capture. Got it? If you send the image in nadir 90 degree, then there is high probability that entire amount will come back to the detector. So, they used to make an angle, so that some part will be speculative, means some part will go through a specular like that, some part only will come back to the detector to avoid the 100% reflection. So, LIDAR data processing, that is your file format is your .las file. So, today if afternoon session if you see, then you will see the LIDAR data file format is .las file, it is called. I think in most of the optical you are using .tif file, I think. TIFF file in LIDAR also can be converted to TIFF file, but raw LIDAR data used to come as a LAS file. So, I am not reading these things, so many texts will be boring for you. Some processing, your processing of LIDAR data, what are the basic things, text I am not going to write, but you see the components. Ground filtering is one of the important processing component. Then so, since I told you LIDAR data are mostly used for your urban planning. So, one is your building detections, extraction and reconstruction. LIDAR data are processed for this purpose also. The steps it is written, what are the models and all used. So, I am not reading the thing. So, you can refer this and you can read later on. So, this is one part. Then tree construction, because this is LIDAR data is used for your tree volume and your timber volume tree height estimations also. That is another area where LIDAR data are processed. So, those references are also given. If somebody is interested, they can go through. Then road detection, because I told civil engineers require a lot LIDAR data. So, steps I have given. So, what are the strategies taken for road detection? Then segmentation. Segmentation, in segmentations actually it is your LIDAR in previous, the difference I am, let me tell the difference between the previous your building reconstruction or reconstruction and segmentation. In segmentation, in other two cases it was specific for one purpose. In segmentation it will try to extract the different land uses. So, others are for only one class of interest. So, either it will be building or it will be road, but in this case they will be extracting the information for entire land use or land cover. So, let me tell, in processing there is one part that is most important is your interpolation, because LIDAR are point informations. Point informations to be converted to your spatial information. So, interpolations are required. So, different interpolation techniques are there. So, those techniques are, I think those are available in softwares also, but basics you may read. So, kriging is one important interpolation technique. IDW is one, inverse distance weight. So, these are commonly used interpolation techniques. So, this is your schematic representation of processing. Okay, in the your you see I have mentioned you tree reconstruction or tree construction. That vegetation is how nicely it has come in that right your bottom corner image. So, those are the techniques used, in processing part. So, thus this way the output comes, means after processing. So, these are some of the softwares your available for LIDAR data processing. So, in fact, LIDAR data commercial softwares are also used for LIDAR data processing. They have tools like your ArcGIS and AirDAS, they also used to have, but those are extension tools and you have to purchase. But here most of the softwares are freely available. In fact, first one is not, because it is embedded in NV. Okay, some of the softwares also have given if somebody is interested. Now coming to the final thing, applications. So, I told you that LIDAR data can be used for your JAD information. So obviously it will be used for generating the elevation model, since you are getting jet information, and you see the accuracy 1 meter. Okay, do you know the your vertical accuracy of Cartosat DM, Carto DM commonly known as Carto DM? You heard or not? In somebody has told you about this word. So vertical accuracy, how much Carto DM? 10 meter. So lidar is means 10 times accurate. Okay. So estimation of tree height and timber volume. Since I told lidar data are extensively used for forestry also. So for forestry people, this can be used, but let me tell you, very expensive. So that is why for generally for natural resources management it is not used. These are, I think, for some research purpose only. I think they have done this. But biomass estimation also lidar are used. Of course, these are research purpose, not your operational. 3D city model, what I was telling, these are but operationally used. For field applications, lidar are used in your by urban planners. So this is also your urban planning, their lidars are used. And this is also urban planning. They are categorizing. You see, they have categorized into 4 types. Type 1, they are writing from vegetation to means your building. That means you are clearing a vegetation to construct a building. Type 2 is your, they are increasing the floors of the building. Means if it is a Assam type house, then they have made buildings from them. Third is your demolition. Third is the reverse case. Means there was a building but it has gone down. And fourth case is your minor change. So in 4 categories they have done. So mostly urban planning only. This is also. This is a nice lidar image you see for railways. Then power transmission. So for asset mapping means they can be used. And this is another area where lidar is most extensively used for floods and disaster management. So this is here later here it is used for your landform studies. Alluvial fans are identified using your lidar data, because since they are giving your JAD information, that's why this type of information is coming very clearly in lidar data. Snow depth, it is also important for our region because we have lots of snow areas mostly in upper heights of Arunachal and Sikkim. So we have a scope for that. Coastal applications, we have little scope in northeast. This is important for northeast because mining, we have lots of mining, in fact coal mining, limestone mining areas. So for those subsistence and others, your things, lidar can be used. Even you can get the areas, how much is displaced and how much is the areas, dumping areas, you can calculate, because that information you are getting. So you will know how much of areas has been digged and how much of areas have been dumped. So those informations can be studied. Mining lease areas you are telling, na? That lidar can be used for that. But the problem is that that is the problem, that expensive. So mining lease means a private body used to take the areas in lease. So whether they will consider for lidar sensing or not. But UAV they are using. UAV survey they are doing, mining people. So this is also not so common in our region, sand dune migration. You will see in your arid regions like Rajasthan and all. So volcanic. Oh, migration means you see, lidar, I am telling lidar is giving jet information. That means if a dune is shifted from one point to another, so the point from where it is shifting, so elevation will go down. The point where it will be depositing elevation will go up. That is the basic principle to identify the dune migration. Sand dune means desert. Like in deserts you used to see, no? Dunes, undulations. So in volcanic studies also lidars are used. Oh, finally I could finish exactly in time. 11 I told, 10:45 to 11. So it was an exhaustive lecture, but I feel that you could bear because I was going very slow. That is. Oh, बढ़िया है तब तो. बढ़िया है, we can interact then. We can interact. उनको मैं थोड़ा रिफ्रेश भी करवा रहा था ऑप्टिकल रिमोट सेंसिंग. So, लेकिन आप लोग अच्छे से ऑप्टिकल रिमोट सेंसिंग रिकॉल नहीं कर पाए. So what I was telling that if you have to understand lidar, you have to know the disadvantages of optical. Then only you have to know why lidar is required. So those. ठीक है, because you see in China and Japan now what they used to do when a kid grows to a age group or 4 to 5, what they used to do, they used to send those kids to science congress and they are asked to sit simply. That means what? They are bombarding. They will not understand anything, but they are allowed to hear something, means repeatedly. For science congress used to be for a 2 week or maybe 2-3 days. So they will listen to many hi-fi things. So out of that, at least 1% if they capture, it is good for them. That is the reason, and that is the reason you see how China and Japan they are growing. They also know that kids will not understand anything. Just bombarding means out of that 1% also captured means it is warranted. So it is not that you will not gain. You feel that I am simply sitting, but no, you will absorb something from here. By that day you go out from here, you will carry something. You may think that I didn't learn anything, but you will carry. That is the example I am telling. And that is the way how China and Japan they are creating your human resources. Our people will think that what is the meaning of the kids sitting in that congress, but they are thinking that he may get 1%. That hope also they are not losing. So we are also keeping that hope that after 21 days you will carry something from here. Now can you tell me the basic difference between lidar remote sensing and your optical remote sensing? One reason you tell, one difference you tell. I have given almost 1 hour 15 minutes lecture. One reason how lidar remote sensing is different from optical reason, because lidar is also light detection, optical is also light detection. How it is different? Huh? Okay. In optical also, let me tell. In optical also, have you heard about cartosat? In cartosat, we used to get jet data, but cartosat is not lidar data. Okay. Yeah, that is all. But in general, you are correct. You are correct that lidar in every case you will get jet data, but in optical in every case you will not get jet data. But there are exceptions, like your cartosat. But in cartosat, how we used to get the jet data? Do you know? Jet information, how we used to get in cartosat? Because I told you to get the jet informations, you have to acquire the signal from one point in multiple times. Then only you will get. In cartosat, how it happens? In cartosat, same points they used to capture from 2 different locations. From this angle, it is called cartosat stereo pair. From this location, they will capture once this point. Okay. Then satellite will move. From this location also, they will capture in this one. So same place they will capture from 2 locations. 2 locations, and the jet information will come. That is called cartosat stereo pair. So it is correct, but your answer is correct that optical generally they don't give jet information, but there are exceptions. The example I have given, cartosat is the exception. Cartosset is optical, but it used to give JR information. And anything, any more? Yes, leader's resolution is higher than the optical. Okay. One more. By the time you have tea, one more reasons. If it comes, then I will feel that my lecture is fruitful. Any more reason? You haven't given the first actually difference. Opticals are always passive. Leader is always active. That is one.
Other instances in Northeast or Assam where the leader data has been used.
Yes, yes. In Guwahati city, for Guwahati city, we means I think NRSC has leader data, because for your flash flood management, they have captured the leader data of entire Guwahati city. So, and it is used by your state disaster management authority. In fact, we have also one team, your water resources team. They are using the leader data of Guwahati city, mostly for flood management. That is why I was telling the price of that. It is very expensive. It was charging around 15,000 to 20,000 per square kilometer. So that is one disadvantage of leader actually. So what is your master's subject?
Here it is geotechnical engineering.
Geotechnical engineering. It is related to your environmental impact assessments and all, or?
No sir, it is soil mechanics and foundation engineering.
Okay, okay. They have civil engineering. So shall we start? I feel another one round. So another 1 hour maybe we will discuss on this thermal remote sensing. Okay, here this time also we will discuss in 6 sets. So history, principles, sensors, then image processing, image interpretation and applications. So these are the areas which we will try to cover. This time you see the history, when it started. Last time it was in 1980s, but this time it started in 1800, but still emerging. So actually history means it was the discovery of the EM, electromagnetic spectrum, only in 1800s. So thermal, I think it is the simplest form of remote sensing, I think. So I think all of you have the experience of thermal remote sensing, or if not remote sensing, the experience of thermal sensing you all used to have, I think. No, don't write. They are going to share. Yes, don't write. Today you only you leave your books and pens. We will discuss. We will discuss. Need not to write. Don't think that though many of you are students and many have just passed out, but you come out from that mindset that you are a student today. Because today we are all colleagues. We will discuss only. So in that discussion we will try to understand something maybe. So now you tell me, who are the people having experience of thermal sensing? I think everybody is having. Have you ever measured your temperature, body temperature? That is thermal sensing only, isn't it? But is it thermal remote sensing? Because while measuring your body temperature, how you measure? Thermometer, where you used to put the thermometer? Is it touching your body? That means it is not remote sensing. But you imagine during COVID time, the malls and other places or airports, how they are measuring your temperature? Do they touch you? Is that your remote sensing? That is remote sensing, but it is not exactly remote sensing because the distance is not so much. But it is a kind of remote sensing. What we used to tell that is called proximal sensing. That means it is going very close to you but not touching you. That is called proximal sensors. Okay, that is where the person who is taking your temperature measurement in your airport, malls or hospitals, that is your proximal thermal infrared remote sensing. So everybody used to have that experience. That is why it started so long back. This technology started. Now we are using this for other purposes. Other purposes. So the history is there, and slide will be shared with you. You will see the things, and you will see many other things also. So now from this slide, can you tell me the difference between thermal remote sensing and lidar remote sensing? TIR here it is means thermal infrared remote sensing, I am telling, because thermal region is overlapping with the infrared regions. That's why I am writing thermal infrared. From this slide, can you tell the difference between lidar remote sensing and thermal remote sensing? Can anybody tell me? You take your time. If you can tell this difference, then I will feel that my first lecture was fruitful and I will get energy to proceed with the second lecture, or not energy, inspiration to proceed. Yes, Here source of energy, you see, sun is the source of energy in thermal. Sun is the source of energy. That means this is active or passive? This is passive remote sensing, because source of energy and source of detectors are different. So that is the basic difference. In LIDAR, source of energy and source of detector was the same, but here source of energy is sun. Sun will come to the target. Target will get heat. Then heat will be. Then in case of heat, it is actually not exactly reflected. It is emitted. There is a difference between reflection and emission. Do you know the difference? Reflection means the energy will come and immediately it will go back. But in emission, energy will come, it will interact with the target, then only it will go back. Some energy will be absorbed, some will go back after some time. That is emission. So it is not a instant process. So energy will come from sun. So objects may take some time. That means if you can observe after your incidence of energy, that means what? It can work day and night, because you need not to record it at the same time. Sun will give the energy to the object, so you will wait for 12 hours. Then after 12 hours also you can take the record. That means from that angle, this remote sensing also is important for your intelligence or military purposes, because military people, they want to observe the things in night time mainly, and we the natural resource managers, we used to see the things in daytime. So it is told now, daytime is good for good people, night time is good for bad people. So our interest in daytime, their interest is night time. But both LIDAR and thermal, and in fact your microwave, they can work day and night. Day and night they can work. Though thermal is not, generally the active sensors used to work day and night, but in case of thermal it is exception. It is passive remote sensing, but since emission is there, and you know emission, but the slide will come, I will not tell now. Emission means the object, you know the temperature of a object to emit, what is the minimum temperature required to emit? We will come, you will be surprised to see that for emission, so less temperature is actually required. Do you know 1 degree Kelvin, how much is the centigrade? 1 degree Kelvin is how much of degree centigrade? That is the actually temperature required to emit. You may not know, but you too should know actually. You are civil engineers, na? You too should know. It is minus 273 degree centigrade and Kelvin relationship. That means a object having minus 273 degrees centigrade of temperature can emit. That means anything in the earth can emit. So minus 273, so we cannot imagine even so low temperature. That means including glaciers, snow, everything will emit your radiation. Okay. Again the same slide has come for you. I told you that in each case you will see the same slide. Here the range is a bit different. Oh, this the same slide, yeah. Here it is showing minus 270 centigrade object or above will emit. Then that emission can be recorded. So that means any object present in the world can be detected using thermal remote sensing. It is different. That we cannot differentiate, but it will emit. It will emit, but it may overlap with some other objects. That is different case. And our range this time, you see, our range is your 3 to 14 micrometer. Okay. Can you remember in LIDAR what is the wavelength we considered? Can you remember what was the wavelength we considered for LIDAR? Here I am telling 3 to 14 micrometer. 600 mostly. It was micrometer? It was nanometer. Then what will be the micrometer for 500 to 600? Divided by 1000. Nanometer and micrometer difference is 1000 times. Micrometer is 1000 times higher than nanometer. That means 500 nanometer is equal to 500 divided by 1000 micrometer. That is 0.5. That means 0.5 micrometer to 0.6 micrometer we were using in LIDAR. But in some your multispectral LIDAR, you can remember, there we went up to 1500. That means 0.5 to 1.5 micrometer we have considered for LIDAR. But here we are starting from 3 to 14. And you see the Earth's surface emission is at 9.7 micrometer. That means our Earth emits at 9.7 micrometer. Fine. So, in case of your passive remote sensing, one thing is very important, atmospheric window. I think it was told in optical remote sensing also. Atmospheric window, you know what is atmospheric window? Window means what? In a building, this room, you see, we don't have any window. That means if this door is locked, how can you go out? You cannot go out. That means atmospheric window also same. If you have the window, then only emission can go out. Emission has to reach the detector, isn't it? So if you don't have window, you cannot reach the detector. So these are the, in this slide I am showing the atmospheric window through which your emitted energy can reach detector. So here peaks are the actually windows. Where you are seeing the peaks, those are the windows. And where you are seeing the drops, they are the walls. Means those are the areas where your emission is not allowed. And who are the culprits not allowing emission? You see, carbon dioxide, water, ozone, those are the culprits. So that means they are the objects interfering emission. Got it? So atmospheric windows are the areas through which emitted energy can reach the detector. So you see here in and around your 5 to 7. So water absorption is most dominant, isn't it? Wavelength 5 to 7 micrometer. That is the area. That means if 3 to 14 is our range, then 5 to 7 is gone. Like that means. And there is a area in and around your 9 to 10, you see, there is a ozone absorption area in that. Ozone used to absorb the emitted energy. So atmospheric window is a must for remote sensing, whether it is thermal remote sensing or optical remote sensing. Okay. Now you see, since it is thermal, we have to know the relationship. Actually, there are many laws. There are 3 laws actually working on this, but I am showing one thing here. You see, the relationship between your temperature and your wavelength I am showing. That means if your temperature is increasing and wavelength is decreasing, isn't it? You see, in the horizontal axis, wavelength we are showing 0 to 100. In the vertical, we are showing you have seen in the ellipsoids, you are seeing the temperature. Temperature is increasing, you see it is coming towards the left hand side. Got it? That means our range, you see, our range is 3 to 14 micrometer. 3 to 14 is coming in which range? It is around 300 to 400 Kelvin, isn't it? That means our temperature range is 300 to 400 only. That means now you tell 300 degree Kelvin is how much of centigrade? How much of centigrade is 300 degree Kelvin? Now I expect everybody to answer this. Initially I expected only 2 civil engineers, but today, not today, now I expect everybody to answer because I have given the answer, I have shown in slide also. 300 degree Kelvin is equal to how much of degree centigrade? At least these things you will learn, may not be something to you have to learn from me. 1 degree centigrade was how much your Kelvin? Minus 273. Okay, minus 273 equal to 1. Okay, or 1 equal to minus 273. 273. Then minus 300 equal to how much? It is 27, I think. 300 minus 273 equal to 27 degrees centigrade. Isn't it? 27 degrees centigrade. So 20. Actually, when we started our education, that time even calculator was also not there. So the problem is that even that is not your problem. It is the problem of technology. So in my son's case, though, he will be worse than yours because he is so fond of technology. He will be exposed to so many technologies, need not to know or recall many things. In our case, what happens? We didn't have much support. When I went to primary school, I haven't seen mobile, calculator, nothing. That means we have to memorize these things, many things. So still we are. That's why we can straightway tell. But in your case, you require the calculator to tell those things. These are the disadvantages of technology. There are always 2 sides of technology. So disadvantage is that you are dependent. I have seen my father, he never go to market with a list. Always, my mother used to tell, he used to go to the market, never miss anything, he used to come back. But I cannot. I always used to have a message in WhatsApp, what are the things to be purchased from the market. So the way, this is the way how we are losing our memory. So that is the difference I have seen me from my father. And my son will be, he will be gone. Even after seeing the message also, he may not be able to get everything. He will skip something, overdid something. So those are the things actually, those are the disadvantages of technology. And the thing I was telling, he was practicing since the age of 79 years. That means since till the age of 79, he need not to take help of any aid. He can simply memorize. Somebody will narrate and see, he will memorize. Okay. Now you see the interaction. I was telling, in case of thermal, there used to be interaction. It is not that quickly, you see. So incoming radiant, some of the radiation will be absorbed, some of the radiation will be transmitted, and some of the radiation will be reflected. Okay. These are the things. These are the 3 components. After here, the energy source we will consider the sun only. Sunlight will fall into the object. Some will be absorbed, some will be transmitted, and some will be radiated. Now you see. So if we consider the earth as a black body, then black body used to what? Black body used to do means whatever light used to, whatever energy used to come to it, it can absorb everything and it can reflect everything. So that is why here it is showing emission is equal to reflection. E, so left side is emission and right side is your reflection, because otherwise emission in this case, you see, emission will be from the absorbed radiation, but we are considering that 100% absorption. Black body is that only. Black body is not only 100% absorption. People used to think that black body means 100% absorption, but black body is 100% absorption and 100% reflection, 100% emission, which is. So, so that means the these slides actually conclusion. Let me draw the last line. You go. That means reflectance in the thermal region. If it is lower, then emission will be higher. You see, let us discuss from here. I told reflection, if it is lower, then emission will be higher, because emission is what? Emission is from absorbed energy. I told you, na, energy will come to the object, it will interact, and after some time it will emit. So emission will not come from the reflected part, emission will come from the absorbed part. So if it is less reflected, that means it will be having more absorption. And you imagine the condition of your sand in desert. Daytime sands are so hot, isn't it? And you go in the night time. If somebody has traveled to Rajasthan, daytime is very hot, night time is very cold, because sand is having your, what happens? They have absorbed the energy and they so quickly emit also. So daytime during the sunshine they will keep the heat with that, and night time quickly they will emit and become cold. But it is not the case in case of water. Water used to become hot very slowly and used to become cold also very slowly. That is why in winter in Rajasthan itself, if you feel the sand is cold, you touch the water, water will be not cold as sand, because it takes more time to become hot and it takes more time to become cold. So that is the case. If reflection is less, then emission will be high, because it will be absorbed and gradually or in later part it will emit. Okay. Now emissivity of some material we are showing. You see, in the last line, other things I will not focus. Polished metal, it is showing very less emissivity. Can you tell why it is? Green color. Green color one, can anybody tell? Huh? Tell. Polished metal. Low emission. No, that is what it is written. Emission is low. Lekin why emission is low? That reason I want to know. Yes, it has high reflectivity. That is what the previous slide's answer is here. So now some sensors I am showing. So that type of slide actually I was asking. I expected that for optical remote sensing also this type of slide would have been shown to you. You see the way in the vertical section how we are going. The sensor name while writing, on the bottom I am writing kilometers. Kilometer is the spatial resolution. The way I was telling in previous lecture I was telling, na, have you ever been taught about the history of Indian remote sensing? I wanted a slide to be shown like this. Maybe Dharmendra also told it was not shown. In optical also you should have seen a slide like this. How you see in vertical, you see how we have improved. It was 1.1 kilometer. Then gradually we have reached up to 1 to 5 meter of resolution. That is the way, means we are improving in thermal. Same is the way how we are improving in optical also. Optical also we have started in around 1 kilometer spatial resolution, and now we have 5.8 meter of resolution for India. But for foreign satellites too, we are going up to 0.5 meter of spatial resolution. Okay. Some of the sensors name I am showing with their spatial resolution. And sensors full form here I have written. So when the slide will be shared with you, you can read that. But one thing, you see, most of the sensors are either from Europe, no, sorry, either from US or from Europe, mostly from US, because NOAA is also US. NOAA, you know the full form? NOAA? Okay. National Oceanographic and Atmospheric Altimeter. Then ESA, you know, I think, European Space Agency, that is European, that means. Again, MODIS is NASA is US. Then BIRD is Germany is Europe again. And again Europe, again Germany. You know why German is so fond of thermal? Because Germans were engaged in your First World War and Second World War. So one of the most important utility of your thermal sensor is your detecting the missiles, tracking the target by a missile, detecting aircraft. In most of the cases, thermal remote sensing can help, because those are high temperature objects and they can be distinguished from the other objects very easily. If a missile is flying, then its temperature used to be very high because fire used to be there. No? So thermal can be used very effectively. So Germans are mostly interested to the technology because they were into war. Okay. Nowadays, actually, more than German. In today's, I was talking about First World War and Second World War. But if we see today's history, then Israel is the most vulnerable country, because they are surrounded by some countries which are putting pressure on them. So recently, they have also developed a lot of remote sensing for military applications. That is true. Yeah. Nowadays, Israel is much ahead in case of remote sensing for military application because of their your geopolitical condition. But otherwise, what I am telling in history, the Germans had in First World War, Germans were there. Second World War also they were there. So many are there. So German sensors are mostly for military applications only, not for civilian. Civilian application you will get from either from NASA or from ESA, or sometimes from CNES. CNES is from France. Okay. So these are some sensors I have mentioned. I am not reading the sensors. You can go through after getting the. Yeah. Now I want to highlight some of the specification of the sensors. AVHRR. AVHRR is your advanced very high resolution radiometer. Okay. In that sensor, there are 6 bands. Out of that 6, 4 and 5. That means let me tell 5th and 6th. That means 5th and 6th are only thermal. Others, can you tell what is channel number 1? Channel number 1 is what? Can you tell? What is wavelength is in which region? Visible region. 2. Yes, near infrared to infrared. 3. Infrared region. Okay. But 4 then last 2 are only in your thermal regions. This is. Then let us come to MODIS. This is actually most commonly used sensor and freely available data. MODIS, let me show you the full form you have or not. Moderate resolution radiometer. Okay. In case of MODIS, actually these data are used for lots of applications, starting from your atmospheric studies and weather related studies and your forest fire related studies also, because thermal can be used nicely for forest fire. Okay, MODIS has 36 bands, you see, so many bands. so many bands are there. So that's why it is most widely used, your freely available satellite data by the people. Then this is another your thermal sensor, ester. Okay, have you ever heard this word ester? Ester DM, have you heard or not? Ester DM you haven't heard actually. Carto DM you have heard, but ester was the one who actually, ester data also gave digital elevation data. Elevation data we got from ester. Ester is 20-meter vertical resolution data, but nowadays Carto DM has come, which is having 10-meter vertical resolution. That's why people forgot, but otherwise ester was dominating before Carto DM came. And in fact, for hilly regions, ester is better than Carto DM sometimes, but best was the SRTM. SRTM was the best. SRTM is actually, do you know what is that? Have you heard about SRTM? In microwave, have you been told? SRTM is subtle radar topographic mapper. That means it is radar sensor. The ester is again thermal sensor. And Landsat, I think Landsat you have heard. This is also most commonly used freely available satellite data. So Landsat is having many bands. So out of that, they are having 2 thermal bands, band number 10 and 11. And now, but Landsat 9 also has come, I think. So this slide is a bit older. That's why up to 8 it is shown. But Landsat 9, I am not so sure whether they have 2 or more than that. But at least 2 thermal band they will be having. Generally, they used to retain minimum numbers. If 8 is having 2, that means 9 also will be having minimum of 2 thermal sensors. Then in case of ester, you see they have your bands in all regions. VNIR means visible and near infrared. SWIR means short wave infrared, and TIR is the thermal infrared. So ester is having so many 14 bands. 14 means they have 15 bands in fact. 3 is having 3N and 3B. So 10 to 14 or 11 to 15 are your. But you see the resolution. In case of thermal, resolution used to go down. In case of thermal band, always in Landsat also you will see thermal resolution will go down. Here it is showing the resolution or not? Oh yes, it is. Yes, band C, you see the other bands they are not showing resolution. But in case of here Landsat 8, thermal they are showing 100 meter. Do you know the Landsat your multispectral resolution, spatial resolution of multispectral bands or optical bands? Can you remember? Landsat 2 you have heard, everybody told. What is the spatial resolution? Yes, 30. So thermal bands always used to have your lower spatial resolution. But you see, we used to tell the word lower, but the number used to be higher. While telling, I told that lower spatial resolution, but it is 100 meter. So that at least I think you understand. The number we used to tell reversely, because more the number is less useful for us, So this is another sensor. So here all the bands are in thermal region. This is used for volcanic studies. Teams was from which country? I forgot. Let me see. Teams was from which country? NASA's only. Thermal infrared multispectral scanner. Teams was NASA only. Okay. Now this is the trend, the way I told for LiDAR also. So nowadays your UAV borne thermal sensors are used. So I am showing a figure, but specifications are there. But here also the problem is that payload capacity. So getting low weight sensor is the challenge. Low weight This is handheld thermal sensor. This is quite similar to your the sensor used in airports and all. But can you tell the difference? Seeing this, what is the difference between the from here? Actually, I should have put the other image also, then it would have been easy, but I should not give spoon feeding also. You tell what is the difference between the proximal thermal sensor used in airport and the thermal sensor shown in this image. I am igniting your minds in Abdul Kalam's word. In the airport, what you used to see? Temperature in what? Numericals? Here what you are seeing? That means the airport sensor, what they are using, that is non-imaging. Non-imaging, that is digital only. You will simply see the numbers, numericals. But here you see, you are seeing one image. This is imaging sensor. Imaging sensor, another one is non-imaging. Imaging sensors are always expensive sensors. Non-imaging, they are you will get in 1000 rupees, 2000 rupees, 3000 rupees maximum. So, but these imaging sensors will be in lakhs. So that is the difference. This is imaging handheld sensor, and what people are using commonly, they are non-imaging. Only digital number you will see. Here digital number also you are seeing. You see the range they are showing 14.2 degrees centigrade, and scale bar they are showing maybe 10 to 14 temperature. Yeah. So this is the difference between what you used to see commonly and this one. Now come to the detectors. What are there are actually three main detectors. It is in your thermal, three detectors are mainly used. One is indium antimonide, second is mercury based, and you see third one is the most commonly used. Why it is most commonly used? Your sensitive range is higher. First one is only, it is sensitive in 5 micrometer, you see. So that means you may get only one specific target, and in case of second one, it is sensitive in 10 micrometer. But for us, actually, if we get a range, it is always better, so that we can get the idea of all the objects present in the coming to the sensor. So last one is always useful. It is giving the range of 8 to 14 micrometer. But still, you see, 3 to 14 we are not covering. 3, because in the first slide I told thermal remote sensing we consider 3 to 14 micrometer. But why less than 8 we are not considering? Because in can you remember 5 to 7 it was absorption by water. That is why mostly thermal remote sensing starts above 7. Because less than 7 most of the emissions are absorbed by the water vapor. Okay. So in image processing, so since they are sensitive to many parameters, mostly atmospheric parameters like water vapor, ozone and all. So atmospheric correction is a must for thermal remote sensing data. Okay, and there are two methods mostly used: empirical line method and radiative transfer model. Okay. In line method, you see, it is a linear ligation only. It is the simplest method actually. It is the simplest method. So empirical line method, and actually these methods, your what to say, principle if you learn it is good. Otherwise nowadays softwares are taking care. Only in a click of a button you can do the processing. but the background I am showing here. Otherwise, in your if you are intended to use thermal data, it is not that you have to write this code. Software will take care. They have modules, they can take care. So need not to worry for this. Means these steps are simple for you if you want to do. And another one is your radiative transfer model. So these are two methods mostly used for atmospheric corrections. So image interpretation. So here we are showing one image of NOAA. So left hand side is the daytime image and right hand side is the your nighttime image. From this image, can you see what it is trying to interpret? What is the scale it is showing? In the right side there is a small scale bar, narrow scale bar. It is showing the temperature in degree centigrade. So what it is called? This is showing the diurnal temperature difference. That means temperature difference in day and night. What I was giving the example of your Rajasthan area, this is typically shown in the image. Daytime they used to have higher temperature, night time they used to have lower temperature. In daytime you see the ranges are temperature are mostly red to yellow. That means it is from 20 to 40 you can say, or may go up to 60. But in case of night time you see they are blue or cyan or yellow. That means they are 0 to 20. The difference you see, same place, same day. So thermal image, that is one of the biggest advantage of thermal image is means day and night time temperature studies globally you can do, and this day and night time temperature is very important for global climate change. If you have more difference in day and night, that means that area is more vulnerable to climate change. I have given the example of Rajasthan, but you will not get the same day and night difference in northeast because we have lots of vegetation. So day and night temperature difference we don't have much. We may have a difference of maybe 10 degrees centigrade day and night, but they are having difference of 20 degrees centigrade. So more the difference in day and night, more the vulnerable to climate change. That is the implications, why it is so important. So again this is actually showing the seasonal variation of temperature. So winter is always cold and temperature range is your 0 to 44 degree. So thermal image you see the how nicely one building has come in thermal image. So sometimes if the resolution is high, the way I was telling that 1.5 meter of resolution is very high resolution. In that you can get everything clear. All objects will be clear. So now I am coming to the thermal remote sensing applications. Okay, in agriculture, thermal remote sensing is mainly used for estimation of moisture in soil, because temperature and moisture they are inversely related. If a soil is having more temperature, then it is expected that it will be having less moisture. So you see the correlation here also. In the left side it is showing the temperature map, and in the right side it is showing the yield map. You see where the areas where temperature is high, those are the areas showing less yield also, isn't it? And it may be interpreted that the less yield may be because of less moisture. That may be one of the interpretation. So this is one your onion field it is shown. Onions are grown in narrow lines. That's why the image is coming in narrow lines only. It was zoomed in to show you clearly. So the way then temperature difference you can see, and here it is yield relation. Actually map is not there, yields were shown in figures, but here also same is the case. If you are getting less temperature, you used to get more yield. That means expecting that there is no shortage of moisture. In forests generally, your thermal remote data, they are used for forest fire monitoring because it is very easy. Fire pixels will be obviously showing higher your temperature than the nearby areas. So it is very easy to pick up fire pixels in your thermal remote sensing, and it is globally used. Thermal data are globally used for forest fire monitoring. So this is also forest fire monitoring in African region. In fact, in our northeastern region also we have forest fire monitoring using MODIS data, and those data are available in your disaster management portal of NSAC. It is called NERDRR portal. So in the last lecture I will show you. So I have another lecture, unfortunately. So in that I will show you the data available in those portals. Okay. In oceanography, sea surface temperature is used, AVHSR, that is, can you now remember and radar now? You told here radiometer. What is the difference between radiometer and radar? I told you in the last lecture. Huh? Yes, radiometers are passive sensors, radars are active sensors. So volcanic studies also they are used, obviously, because in volcanoes there will be having temperature difference. So in urban also it is used. I have shown one better urban image actually in the image interpretation part. This is a schematic image only, but you have seen the urban image, how urban buildings are clearly visible. And mostly actually thermal and lidar, thermal and microwave, they are used in your military applications because they have your day and night monitoring capability. So you see how the people can be seen even in the forest also, in the hilly terrain, to track the people. You have seen the Uri movie, I think, no? There also people were tracked like this. So military applications, thermals, they are very useful actually, because I told you, no? So in emissivity, I told you what is the body temperature of one person. Average you tell, in degree centigrade you tell, or in Fahrenheit you tell. Huh? No, 37 degree is the standard, or 98 degree Fahrenheit. Huh? Centigrade, not 32, 37. 37 degree centigrade is the standard actually body temperature, and 98 degree Fahrenheit is the standard body temperature of one person. So that means a person, if he is moving in a hilly terrain in jungle, his temperature will be always higher than nearby vegetations and soil. So he will be highlighted in thermal. So this is the way it is showing. 37 degree, and vegetations will be having hardly what? It may be 27 degree. I told you, no, what I told. Yeah, in Kelvin and temperature, 300 degree Kelvin is 27 degree centigrade. So that can be nicely differentiated. And for animal tracking also, thermal can be used. Same is the case because animals are generally warmer than the nearby environment, so they can be tracked. So animal tracking also it can be used. Okay, I told I will take up to 12:30, but luckily I could finish before 12:30. So this is about thermal. So 5 minutes we can discuss, or we can discuss something else also before going to the next, because it is difficult to actually listen for long. Actually, a person's your reception capacity, you know what is the standard time. It is 20 minutes. A person cannot listen to one person more than 20 minutes, and you are going to listen to me for 3 hours. That I understand. That means out of 3 hours, only 20 minutes you can capture. Others are only bombarding, I am telling, like you're in China and Japan, what people are doing. Others are bombarding, simply throwing. But that 20 minutes, at least if you can grab that, it will be a success for me. We have actually another component, I think, in the first slide when they were showing a WebJS component also. So in emerging technologies, actually 3 components were given to me. One is LIDAR, second is thermal, and third is WebJS. So I am not a person from WebJS, but simply I will try to give you some basic idea about the WebJS and what are the web portals we have, or nationally we have in the country. So in that we will not take much time, maybe 15-20 minutes we will take for that part. Actually it was supposed to be a full day program, but the practical sessions I wanted to be in the same day, so that it is easy for me. Instead of spending whole day with you, you also will not feel good to see the same face for the whole day. So I will show my face for half day only. After lunch you will not going to see my face. So you want to go out for 5 minutes, or going out will be difficult. Actually. If you go out, you cannot come back in 5 minutes. So you can take rest, or you can discuss some other thing. I don't want to. Yeah. Yes. finally coming closer to the conclusions. So this is the last component we are going to discuss. So WebGIS. So I think by this time you understand about GIS. Okay, GIS full form everybody knows. So GIS you know, then you know the common softwares used in GIS. What are the softwares you are using in practical section? ArcGIS and ERDAS you are using, QGIS. Okay. So actually, in GIS, the major problem is most of the GIS softwares are commercial softwares. Of course, QGIS is a freely available software, but most of the capable softwares are like ArcGIS and ERDAS. They are highly expensive. So considering that, actually, this WebGIS concept came to encourage your freely available softwares, or for some at least basic level of processing if somebody can do, or interpretation somebody can do using freely available softwares. That was the idea actually, and we will discuss this in this class. So, so in web technology, actually, in fact, in GIS also this applies. Okay, I will not tell actually this is exactly web technology. It is the same principle which is followed in GIS also. But in case of web, actually you see they have two main components. One is server, one is client. I think in others also the same is the case. If you say ArcGIS, then also you have the client. Means if the license are shared, one license can be shared by 10 persons. So that means all 10 systems are client, and the core systems where the license key is there, it is your server. So in WebGIS also I am showing the same thing. This slide is actually not different from your other servers. This is common for your commercial and your freely available. So servers actually what it does, it receives requests, it processes requests and return results. Clients, what they do, handle user interaction. Client means here it is not considering the person, it is considering the system. Okay. So it sends requests. Obviously in ArcGIS, if you are doing something, what practicals you have done so far? What practicals you have done so far? Can you recall? Okay, down then. Georeferencing. Okay, you see, in classification or in georeferencing, you will ask for your masters in georeferencing using image to image georeferencing or GCP georeferencing on GCP. Okay, GCP used to call from the server. GCPs are already stored in the system, I think. So client will send the request for georeferencing. You imagine, you consider georeferencing. You want the GCPs, then you will send your request. Then your server will send you the response. Then you will process the response. So you means your system, not the person, I am telling. So in both the cases, they are actually software. Whether it is server or client, it is client. Though in general, client we understand by person, but here client is also your system, the system in front of which you are sitting. So these are the main two components. You see, the last case, there may be many clients. What I told, ArcGIS license used to have multiple users. They are replicates. Now we are coming to servers. So common servers, they may be file servers, they may be web servers, they may be database servers, these are the 3 types of your servers. Okay, file servers means it will store and send documents only. Okay, GCP will be of what category here? GCP will be, I think, a file server only. GCP will come from a file server only, because it will come as a file only. And web server, it is store and send web pages, because GCP will not come in the form of HTML and all, I think, isn't it? It is to come in text file, I think, generally. And last is your database server. So in a single server, what it means, all clients have access to the same information. That means if you consider a ArcGIS license, and you are all, I think you have only one license, I think. No, or all systems are having independent license in your practice. Independent license. The systems are standalone license. Okay. Oh, got it. Acha, you got that trial version. Okay. Oh, in your case, it is not server client based. You yourself become a server. All system has become, that means server. Independent license means you are all servers in your practicals. Okay. Yeah, got it. But independent license means I cannot tell you as a client. You have become server once you got the license. So I cannot relate with your practical means now, because what the sentence I wrote, you see, all clients have access to the same information. It is valid only when you are using a common key, but you are not using a common key. You are using your own license. Okay, but theoretically you understand. Then any change will make accessible to other clients also. This is one thing, and server has to deal with and resolve multiple editors. That is true. That is true, because many people will give many queries, and server has to respond accordingly. Somebody will do georeferencing using the same software. Somebody will do image classification using the same software. So multiple purpose it has to fulfill. So this is the architecture. So in the architecture, actually there are two main components. SOAP, it is your simple object access protocol, and second is your REST, it is your representational state transfer. But if we see the architecture of URL, so it has actually three major components: protocol, host name, and file name. You know, any I think any site, if you have a page, then the page has to be either HTTP, or nowadays if people are in a closed environment, or in a restricted environment, or in a secured environment, people used to use FTPs also nowadays. This is secure sharing of data. HTTP is actually, security is less, it is mostly open access, or maybe you can restrict through user ID and password. But in FTP, they are also restricted through user ID and password, but they are more secured. So generally government data are transferred not through HTTP, they are transferred through FTP. Maybe when you will be working, C is working in Nectar, if they want to transfer data from Shillong to maybe Guwahati, they will not prefer HTTP, they will prefer FTP to transfer. So generally government sector people, they prefer FTP formats. Okay. So now coming to the open sources. So till the last slide, previous slide, it was common for commercial and your open sources. But now we are coming to the open sources. So they are open in what are the aspects? That though they are open as free, that means though it is open, it has they are free also, freely available. They have open access, that means they are free and anybody can access. Okay, and they are free over time also. It is not that yours is 6 days, you see, because ArcGIS is a commercial license. They are giving you free access, and they are giving you, in your case I am giving you the example, in your case first point is valid, you are getting as a free. Okay. And second point, is it valid for your case? Open in access. You are using 6 days validity license, you are telling now in ArcGIS. Do the second point fulfill your case? Okay. No, but still, let me theoretically consider 6 days. Okay. In 6 days, it is access to this group only. It is not that I can use. That means it is not open access. It is access to a limited group. Okay. That means first criteria is fulfilling in your case, second is not. And again you see open as in over time. That means over the time it has to be open. But in your case it is 6 days. So that criteria also is not fulfilling. So what I intended to mean that the license you are using, they are not open source license, because you are using ArcGIS, they are commercial license. So in open source these are the criteria. Okay. And you see, and it is not closed. In no case it will be closed. Open means it will be open throughout. Okay. And reuse and change also it will be open, and open in any place and anyone. These are the open sources policies actually. So let me come to the next page. So next page is web applications and web services. So these two words are actually interchangeably used, but there is a difference in applications and your services. Applications are meant for your end user oriented actually, and services are not intended for the end users. In case of applications, actually GUI is a must, graphical user interface, like your mobile applications. All people nowadays, you people always, everybody using mobile app in some way or others. They are actually applications. They are not services, because there is a GUI in that system. So it is interacting with the client. But in case of services, GUI may not be there. That is the difference actually. So applications are most useful for illiterate or ignorant, and services are useful for the experts only. So open sources or web services is useful for your experts, and applications are useful for illiterates or ignorance also. Okay. Now coming to open sources GIS. The last slide, up to last slide, we were not mentioning about GIS. It was mainly means web applications, may not be the GIS applications, normal web application. Now we are coming to the GIS applications. So it started in the year 1994 and forming one consortium. It's called Open Geospatial Consortium. So you see the standards, what they are, your geoportal services, what they have made, that is web mapping services, web feature services, web coverage services, and web processing services. These are the things which actually these things are required for a person who are developing the open sources GIS software. As a we people, you be the client only or user only. So we may not require these things, just because the WebGIS background also I wanted to give, that is why I am showing. But for us will be the application. So I am coming to the application. So what are the applications available? But actually the basic things you should know, actually what are the components actually used in open sources. Okay. This may not be very useful for you, because I am coming to the one example actually. So in open platform, there are two actually major differences. One is platform as a service. It is provided. Have you heard about Bhuvan? Demonstrated to you? Okay, that means open source is some component taken or what? Bhuvan, it was covered in which lecture? Okay, okay. Acha, Bhuvan they were telling now. Bhuvan actually is ISRO's your geo portal, GIS portal you can say. So they have two services you see, platform as a service and other is your data as a service. So these are also some basic differences between service providing. So but these are about the services, not applications. Okay. Now come to the GIS components. WebGIS components, you see there are three major components. One is your map server, second is your web server, and third is your map viewer. Map server may be your map server or geo server. Web server generally script. What are the scripts we are using that is highlighting? It is PHP based or Java based or Python based. We will show some of the scripts or some of the web GIS your platforms available with us, and they are mostly Java based. What we are going to show you. Okay, and map viewer may be open layers or leaflet. Okay, the software requirements you see for the client. The software we require a browser. Okay, for server we require those XAMPP. Then for GIS server we require Geo server. Then database we require and editor we require. These are the things. So this is the basic architecture of Geo portal. And web portal and geo portal, so there is one difference. Basic difference is, in case of web portal you may get the informations but not the locational informations, but in case of geo portal you will get the locational informations for all data. So that is the basic difference between general web portal and geo portals, because in geo portals always locational informations are embedded. So some of the common your portals for our country and for this region I am highlighting here. So NESD are also covered here? No, I think. Bhuvan they have heard, they are telling. Bhuvan they have heard? Okay. So NESDR is your Northeastern Spatial Data Repository that is developed by our center only, NESEC. NERDRR is Northeastern Regional Node for Disaster Risk Reduction, that is also developed at our center. So NDEM is developed by your NRSC. Then MOSDEC is there. Bhuvan you have already experienced. So SILKS is also developed by NESEC, and VEDAS is developed by SAC, that means Space Application Center, Ahmedabad. These are some of the common your geo portals available in our country. So we will see some utility of these portals in our next slides. So the way I was telling, so forest fire is one of the major problem in our region, northeastern region. So forest fire was monitored using your MODIS, your thermal your bands. MODIS thermal bands were used to monitor the forest fire in northeastern region, and it is used in operational basis. Okay. And in disaster management also we are using. So I have mentioned NERDRR portal, that is Northeastern Regional Node for Disaster Risk Reduction. Here we are regularly posting data on your flood forecasting as well as your rainfall forecast, thunderstorm your nowcast and lightning nowcast. These are the components what we are providing through this portal. So in fact this forest fire also we are distributing through NERDRR only. So weather services also we are posting through NERDRR, and in fact your weather prediction for 24 hours, 48 hours and 72 hours. These are your lead time actually. In this lead times data were posted through any or the other. So MOSDEC we have told you, MOSDEC is mainly used for weather and your forest fire, because no, sorry, not for forest fire. MOSDEC is mostly used for weather related atmospheric studies only. I continue. So this is actually it is available in w.e.f portal, National Urban Information System database. So the details of 152 towns are available in the w.e.f portal. So detailed map, I think these are 1:5000 scale maps are available for 152 towns of India in that information system. So we have done this work for the northeastern region, and the National Remote Sensing Center has done for the entire country. So NESDR, I think some glimpses you have already got. NESDR is a platform where actually spatial database or geospatial database available for northeastern region, they are embedded into one server, so that anybody can have access to database available, because now I think open sources or GIS policy has come. Government of India has come out with your sharing of GIS database among all the stakeholders, and NESDR will play a major role in sharing the data. So we have another important component actually. In fact, this was a very good exercise done by the Northeastern Space Application Center, that is Election e-Atlas. So we are giving support for election management. How we are giving? So I think last slide will show. We are giving, we can track even polling personnels where they are posted in election process, because it is a very what to say, human resource intensive exercise. So we used to have lots of stations, and whether the person has reached that place, because in Northeast we have so many hard areas where a person takes almost 3 days time to reach a place sometimes. So in the control room or in the chief election officer's room, sitting in the room itself, he will know whether all the people have reached their place or not, the things are operative or not. So that kind of services were provided, and this is a very good initiative actually taken for the Northeast, and it may be extended for the entire country. So WebGIS is giving a very good support in your election management also. Oh, finally I could finish before 5 minutes. My time was up to 1 p.m. I told them that listening to for more than 3 is not a 3 hours is not a joke. So still, I don't know how much I could be able to make you understand, but hope that at least 20 effective minutes all you have used out of 3 hours. 20 effective minutes I expect from all of you. These portals are actually free. You have free access. You can see also sites address were also given. Sometimes you can explore some data also you can get. Even online data you can send request and you can get data if somebody is interested. In fact आपका प्रैक्टिकल में भी वहाँ से डाटा उटा ले सकते हैं अगर चाहे तो. मैंने एक प्रैक्टिकल बोला है कि your forest fire monitoring using thermal data, वो मोरिस का लेके